Hi everyone, welcome to the Structurepedia. So today we are going to talk about the series that we are currently running is the principle of computer analysis that we do for the structures, and today we are going to talk about the what is the analysis process that we should do when we do any modeling in software, or when we do any computer analysis for any structure or any kind of structure. It could be building, it could be bridges. And so, before going through the entire process, I would like to discuss some of the key aspects that we do generally. When we get any design or when we get any assessment, we try to uh, see the geometry, the boundary conditions, and the type of loading that we need to apply. And after that, we try to model that in the software and then try to extract the results and just use them in the design, in the calculation. Now, there is a big fault that we see with this process is we just give some inputs, we rely on the software and we get the results, and we rely on the results as well. We assume the results would be right, and there it comes the biggest mistake and biggest issues that lead to failure of the structures. Now, we, I've just simplified the entire process into four stages, and if we just keep ourselves and just we understand these four stages and the entire process, we will never get wrong, and we will always be sure that whatever we have done is right. So the four stages that I have divided into, these are the four boxes. I will come to that later, and before that I will just discuss these arrows that we have. So first one is the model development process, through which the analysis model is defined. So you define the boundary conditions, you define the geometry, you define all the things that you have given in the drawings, or you have the details from the client. Second is the solution process, solution of the analysis model to produce results such as stress, displacement, etc. And the third stage is the output acceptance process, where results are assessed to ensure that they are, as far as can be, ascertained, error free, and answer the necessary questions of the designer. The fourth is the technical assessment, the technical assessment process, where the results are used to assess whether the engineering model satisfies criteria. For example, the strength and stiffness. This and other technical and non-technical judgments may then result in the development of the design. Now, this is the four arrows that we understood. Okay. Now, let's come to the boxes that we have. So first we have the system model. System model is a design information for the complete real world system. This is traditionally in the form of drawings and specification, but also includes BIM models. The engineering model is a subset of the system model that defines the features of the structure needed for the technical assessment. Now then come to the analysis model. The analysis model is a mathematical model of the structure represented by the diagrams, model, specification, data for the software. Third is the solution. Solution is a raw output from the computer. Raw output means whatever you do analysis, you get simple bending moment, but you don't know whether it's right or wrong. So it's a solution. And the fourth is the accepted output. Accepted output is a part of the output that has been assessed and approved for the use in the technical assessment process. Now, how we need to integrate all these things to now we will understand what's going on here. Okay. So once you have the system model and you have all the information that you need for your design. So you get the information from your drawings, and you see what are the boundary condition, you see what is the length of the beam, columns, and you just write down everything in a piece of paper. That then you will use that data to model your structure in any of the software. It could be LUSAS, MIDAS, StretPro, whatever software you would like to do. So that is the model development. So you are using the geometry, you are using the boundary conditions, you are using everything, and you have defined it in the model, the structural model. And once it's done, then what you will do, you will just analyze it. You press the analysis button in the software, and it will solve. It will solve your results. It won't check that whatever the inputs that you have given is right or wrong. It is your duty to do that. It's your part. It's your part to do that analysis. It's your duty basically to check that whatever the inputs you have given, whatever way you have modeled is right or wrong. Whether you have provided the beam and release if there is a hinge, or it's basically your duty. So the model will do exactly what you have given. It won't check the, it won't validate, it won't verify your results, it won't do anything. It's your duty to check whether whatever it is doing is right or wrong. Now the solution process, so it will solve the results, it will give some stress displacement. Now once you get the stress displacement, you need to see that whether your whether if you have a, if you have a simply supported beam, one thing you want to check is, okay, I have this beam and my bending moment shape should be like this. It should be zero at the ends, and it should be maximum at somewhere around the midpoints. So if it's uniformly rotated, this is a quick checks that you do, and some of the checks you can even compare some magnitudes that you can do from the manual part. Now you get some solution. So you got some results, you got some stresses, you got some displacements, you got some bending moments diagram and shear force. Now one thing is that one way is you accept the solution, you're happy with it. How you can check that? By using this sensitivity check. You see some checks and you see the deformation shapes, you see the bending moment diagrams, you validate and you verify your results. Now once you do the validation and verification, and you see though there would be two way from going from this point. So you are standing at this point, you see one way is you see that, okay, my results I am getting is not what I'm expecting. So you validate your model, you verify the results, and you go back to the model development stage, and then you just redefine your model and analyze again to get some solution. But if you're happy with it, whatever the inputs that you have given initially, those were right, you are happy to accept it, then your results are error free. You then accept your results, that is the accepted stage, and once it's complete, then you are fully satisfied with the your modeling approach and your all the calculations. Now there are two things there that I mentioned here is validation and verification. So verification, you need to ensure that your model is error free, you don't get any error in the model. The validate is you need to check the whether the modeling approach that you have done is right for the particular scenario. So if your single beam is sufficient, or you need frames to understand the full structure. So this there could be a different modeling approaches. Okay. Now once this is done, the one thing you also need to ensure, you need that your entire process should answer some of the questions. What are those questions? The question asks what behavior need to be predicted, what behavior you are expecting, whether your modeling approach satisfies that. Model validation is the model capable of satisfying the requirement. This is what I discussed. So whether it's 2D frame, a single line beam is sufficient. So these things you have to understand. The model optimization is the model the most suitable. So can you optimize your model, or you need to what extent you need to go in the model? That is something you need to fix. So that all will come into the model development stage, but your model should answer all these three questions. Now solution process, because when you do the analysis it will give you some results. Now when it gives you results, then there is one question always come to your mind, whether the software is right to give that results. So you need to do software validation. Is the software capable of solving the model? does it have that features needed? So if you want a bar element, suppose that is that you don't want to take a bending moment in that element. So just like when you do Lusa's calculations, so you don't want your your structure, your line element to take any bending moments. So you will define as a bar element, as a truss element, uh, so that can only take axial forces. So this kind of element do your software have or has or not? So this is something you need to check. Otherwise, is software verification. Has the software been subject to adequate quality control? Whether you check that whether your software is capable enough, and has that good quality record or not, and you can always go back to vendor and check it. The other questions you might have is, do the results look right? Because if it looks right, then only you can accept those results. Otherwise, you need to do the validation verification again. Check against estimates made previously. Okay, so what are the estimation you have made initially, and so something you are expecting, and based on your hand calculation, and the similar you are getting in your results is this will give you uh, confidence, the 100% confidence that you are expecting. The other one is the verification. Has the model been correctly implemented? So the same thing. So though there is no error, there is no warning, and everything looks right, then you're happy to accept those results. So these are the so basically in the real design scenarios, the process is often highly iterative, and the process can be repeated many times as the model is refined and the model is developed. Put the analysis process further into context, the analysis is only one part of the wider design process. But the wider design process is often multidisciplinary and complex. So the structural analysis need to be able to develop and flex accordingly. So you need to modify your things based on your requirements, which might change from project to project. And something this is a critical thing, and we're gonna do the complete series where we will go through each and every aspect of computer analysis. There would be many series coming along this year, and stay updated and subscribe to the structure media if you wish to have such more videos and you want to get yourself fully um, versatile and professionally enhanced with the structural engineering knowledge. So I'm a chartered structural engineer with iStructy, and this is something uh, I would like to discuss every time, uh, that whatever you do, it should be right, and because um, life really matters when it comes to the structural engineering calculation. So there's a lot of dependency on you. It's not something cosmetic, uh, architectural thing. It is the safety, health, safety, everything is related to your designs. Thank you very much, and all the best for whatever work you do.